Welcome back. In this video, we're going to be talking about separating our variables with our derivatives. So we're going to go back kind of in our format to our first video of this unit where we have this derivative that's given to us. But this time what's going to happen is we're going to have some x's and we're going to have some y's involved in the derivative. And what we're going to have to do is we're going to have to separate the variables. So what you got to do is collect the y variables on one side, collect the x variables on the other side. You're going to integrate, and then once you integrate, you're going to find the constant value and then solve it for y. A lot of times that solving for y can be the most difficult part. So let's look at some examples. In this first one, I'm giving this derivative as 2x over y. And I'm given this point 1, 4 is on the original graph, and I'm going to have to eventually solve it for y equals f of x. We'll deal with this little star in just a second. But if I separate my variables, I got to multiply both sides by y, so I get y times dy equals 2x times dx. Now, if I want to solve it back for y, I integrate both sides. And I'm going to use my rules of integration on both sides. Over here, it's going to be y squared over 2 equals, this is going to be 2x squared over 2, so it's just going to be x squared plus c. Generally, the arbitrary constant is written on the side with the independent variable. Technically, there are constants on both sides, but we just write with 1. Then we're going to plug in this point 1, 4 to find the constant value. So I get 16 over 2 is 8 equals 1 plus c. So c is 7. So then if I plug that in, I get y squared over 2 equals x squared plus 7. And now I need to solve it for y. So I multiply through by 2. So I get y squared equals 2x squared plus 14. And then I'm going to take the square root. And when I take the square root, because this original point was all positive, I take the positive square root. So y would be the positive square root of 2x squared plus 14. If, like my little note with this star below, if the original point was 1, negative 4, if this was the point, then the equation would be y equals negative square root of 2x squared plus 14. In my second example, sometimes it's not quite as difficult. Like in this particular one, we have e to the y dy equals 2x, and then I'm going to have to multiply this dx over here. So I'm going to write it as e to the y dy equals 2x dx. I'm going to integrate both sides. When I integrate this side, I just get e to the y. When I integrate this side, I get x squared and then plus my constant. If I plug in this point right here, okay, I get e squared equals 1 plus c. So c is e squared minus 1. So then if I go back here, it's going to be e to the y equals x squared plus e squared minus 1. Once I have it that format, now I need to solve for y, and I do that by taking the natural log of both sides. So y would be the ln absolute value of x squared plus e squared minus 1. So again, it's like solving algebraically gets to be the more complex part in these problems. And then finally, the last one involves some ln. So I need to move this y over here and that dx up there. So I'm going to write it as 1 over y dy equals the cosine of x dx. Integrate both sides. On the left-hand side, it's ln, so the ln of the absolute value of y equals, this is going to be the sine of x, 1/2 sine of x plus c. I lost that 1/2, I'm sorry about that. Usually you leave it right there in front of that cosine. If I plug in that original point, I find that c is the ln of 2. Now this becomes the hard part. You end up with this equation, the ln of the absolute value of y equals 1/2 sine of x plus the ln of 2. When you have to solve this for y, I've got to rewrite it as exponential. So y is going to be e to the 1/2 sine of x plus the ln of 2. That's all the exponent. But the way they want the answers written is this way. If we're going to have, what this means is e to the 1/2 sine of x times e to the ln of 2. That's multiplied because when you have two things that have the same base, if you're going to multiply them together, you add the exponents. Now this part of it, e to the ln of 2, that is just 2. So if this is a multiple choice question, they're going to write the answer as 2 times e to the 1/2 sine of x. We're going to do lots of problems like this. So you'll get it. It's that algebraic solving that gets to be a little bit challenging. You got questions on that, please ask. See you in class. I'll clarify as best I possibly can.